C6.4 Electrolysis of Brine. Brine is an impure form of sodium chloride, so it contains other things which are also quite useful. De-icing roads in winter is common use. The products that are made when we electrolyse brine, you need to know. So chlorine is used to make bleach, and it's used as a disinfectant. So it's very good at killing microbes. But it's also good at killing us as well. So we have to make sure we use it sensibly and carefully. Hydrogen, it's used as a fuel, so it burns really well. It's very, very flammable. Its only product will be water, so it's environmentally friendly as a fuel as well. And it can be used to harden fats. So if you take vegetable oil and you bubble hydrogen through it, and you can use a nickel catalyst and warm it up, you can make margarine. So margarine is made by bubbling hydrogen through vegetable oil. And the sodium hydroxide that's left is also very valuable. It can be used to make soap and drain and oven cleaners. So it's a very potent chemical. In terms of safety, when we do this in the lab, we would use this setup where the electrodes are underneath. Normally we have them above, but this time passing through a rubber bung so it's watertight and connected to a power pack on 12 volts. We don't want it any higher than that because the whole thing gets very hot anyway. We don't want that to get any worse. There's always that risk of burning yourself. And the products that are made, chlorine is collected at the positive electrode because negative and positive charges attract each other. And we can collect it in an upturned test tube. This test tube is filled with water, so as the bubbles rise, they push the water level down. It's a green gas, so it is visible. We do this in a ventilated room for obvious reasons because chlorine gas is pretty toxic for us. We don't want that accumulating in large quantities. So we need to ventilate the room, keep the windows open. Hydrogen gas is made in larger quantities. It's very flammable. We collect it in exactly the same way, upturned test tube full of water, and we can test that with a squeaky pop. So squeaky pop test, put a lighted splint in, and for chlorine we can test that with blue litmus paper, it turns white. So chlorine is given off here because it's a halogen. Remember, halogen's always given off first. The OH minus stays in solution. The hydrogen is given off first because it is less reactive than the metal, which in this case is sodium. So the least reactive positive ion is always given off first. So it leaves sodium and hydroxide ions in solution. Okay, moving on. You need to be able to decide which ions will be given off in any particular situation here. So I've given you 4 examples. Now in your booklet you've got some questions which are exactly the same as this, but I thought a bit of practice and a bit of explanation would help. So look at the 4 ions we have in this solution here. Let's call this one A, B, C and D. Okay, so in the case of A, the ions that will be given off, so what you might want to do now is pause the video, have a go at this yourself, and then put it back on and I'll go through the answers. So in A, the least reactive of the positive ions is given off first. So if that's positive and that's negative, it will be copper that's given off and it will coat the electrode. Hydrogen stays in solution. On the negative ions, it will be the halogen that's always given off first. So the chlorine will be given off on this side, and we'll be left with water at the end. So the copper and the chlorine are both given off. In B, the least reactive positive ion here is hydrogen. So hydrogen will be given off first. So let's make it negative and positive. Hydrogen's given off here. And we've got hydroxide and carbonate ions in solution. There is no halogen. So oxygen will be given off at that electrode. Okay, so that's oxygen gas. So that's your hydroxide ion. C, the least reactive positive ion, in this case is silver. So silver will be given off here, and the halogen is always given off first, so bromine will be given off at the positive electrode. Finally, we've got calcium sulfate dissolved in water in this case. The least reactive of your positive ions will be given off first. That's hydrogen here because calcium is much more reactive. So hydrogen is given off from that side. And we have no halogen. We've got sulfate and we've got hydroxide. So it will be oxygen that's given off here. Okay, so in each case, silver will coat that electrode there. So we're going to silver plate. If you ever wanted to know how silver plated spoons are made, essentially your spoon will be this electrode and you put it in a solution of silver and it will coat the outside with silver, and bromine is given off on this side. Okay, and depending on the temperature, liquid or a gas, and on this side we have copper coating and we have chlorine gas given off here, and hydrogen here. Okay, so there are your answers. You will need to know, you'll need to be able to work out, when given a scenario like this, which ions will be given off and which ones will be left in solution. Okay.